HERACLES is a very rapid and sensitive odor analyzer. Its principle is based on gas chromatography of sample headspace. The perception of odor is caused by the contact of volatile molecules on the olfactory receptors of the nose. For example, the coffee odor is produced by evaporation of organic molecules. The odorous compounds diffuse and eventually reach the human nose. The odor mixture contains hundreds of molecules that can be detected simultaneously. The impact of one molecule on overall odor depends on its concentration in air and nose sensitivity. The concentration of that molecule in air is related to its volatility, polarity, and liquid temperature. In consumption conditions, the temperature and ventilation are too variable to obtain repeatable evaluations. For HERACLES analysis, a sample is introduced in a closed vial. The odor will thus concentrate it to the air of the tube that is called the headspace. The concentration of different molecules will rise progressively to reach an equilibrium. This equilibrium will be achieved more rapidly for small very volatile molecules than for large molecules. The analysis of volume of this gas will allow precise comparison between samples. Gas chromatography is a technique of separation of volatile molecules. A mix of molecules is progressively separated during its transport in a long tube column under a flow of hydrogen. Depending on its volatility and polarity, each compound interacts more or less with the compound polymer coating. Very volatile molecules move fast and are thus detected rapidly by the detector located at the exit. Large molecules with low volatility move very slowly and even require column heating to be accelerated. The detector produces a signal displayed on a chromatogram that is roughly proportional to the amount. The peak on the chromatogram thus indicates its retention time in the column and relative proportion in the mix. In short, the chromatogram is a representation of different molecules and their relative amounts. On HERACLES Neo's, two metallic columns of 10 meters with different polymer coating polarity are installed. These columns have a diameter of 0.18 mm and a 0.4 micrometer thick coating film. The sample preparation is limited to weighing a few grams of sample in a vial. The analysis can be made on liquid, solid, or gas using Taylor option. Solid sample may require some grinding to increase sensitivity and repeatability. The vial is then crimped tightly. All the vials to analyze are then positioned on the autosampler tray. Each vial is automatically transported to the heated agitator by the autosampler. The vial is incubated under agitation for 5 to 20 minutes at 40 to 100 degrees Celsius. These parameters allow to generate a good concentration of aroma and a repeatable equilibrium. Then a volume of 1 to 5 ml of sample headspace is aspired. The syringe is heated to avoid condensation and is flushed between assays to avoid aroma carryover. The gas mixture is then injected in the HERACLES analyzer to be separated by chromatography. The headspace is loaded in the injector. The gas sample is transported by a flow of hydrogen to the trap through the valve. The organic molecules are absorbed by the cold trap and the air is evacuated to the vent. After syringe loading, the flow of hydrogen is maintained for a few seconds to flush the tube and the trap and remove the small molecules such as oxygen and nitrogen, but also solvent if necessary. Then the hydrogen flow in the injector is stopped before trap heating to prevent the elimination of volatile molecules in the vent. The trap is then heated very rapidly to 240 degrees to dissolve the volatile compounds. The trap heating time should be long enough, typically 35 seconds, to allow dissorption of all compounds. The gas that is produced represents only a small fraction of the initial injection volume. Then the heated valve is turned to inject this gas concentrate into the two columns under a flow of hydrogen. A fraction of this concentrate is directed to the split to give thinner peaks, thus better resolution but lower sensitivity. The chromatogram acquisition is started at this very time. The chromatographic separation is realized in the two columns inside the oven. The temperature of the oven is controlled by a precise program. The flow of hydrogen can also be increased automatically to optimize separation. The molecules eluted from each column are detected by two flame ionization detectors. The electric signal of each detector is recorded in a chromatogram by AlphaSoft. This software can be used for statistical analysis or to evaluate the quality of a sample using a calibrated model. At the end of the acquisition, the oven and the trap are cooled down in preparation for the next assay. The full cycle between two assays lasts around 8 minutes.